Okay, so next up I have a question on question 11. Okay, so a student conducted an investigation how the heating and cooling of solids affects the expansion and contraction. So heating a solid always causes it to expand, cooling a solid causes it to contract. Then you're given this picture here, and you're asked to briefly explain how a student might heat the solid. So this is my solid, the ring. So I place the metal ring in the flame of a Bunsen burner. And then you're asked, give a precaution that the student would take during the heating of the solid. So take care using heat, never keep the flame unattended, wear lab goggles or lab jackets. So kind of the last two there are your answers. Next then, when engineers are laying railway tracks or designing metal bridges, they take account of any activity in the case of either the railway track or the case of the metal bridge. Briefly explain what the engineer would do. Okay, so what they would do is, remember, I have a solid material, okay, and railway tracks and metal bridges are made of solid metals, okay, usually steel, okay, but can be of many different things. So they'd have to leave small gaps, and the reason why they'd have to do that is, remember, these solid materials expand. Okay, so if this, we'll say, was my railway track, and if I didn't leave any gap, what would happen is that in the summertime, when they'd heat, this here would end up buckling, okay, because it's expanding, so it'd get bigger. This would also expand and it would get bigger, so you'd end up here with it buckling, okay. So what they have to do is they have to just leave, and they're usually very small gaps, just to allow for a little bit of the expansion here. Okay, so they leave small gaps to allow for the metal to expand. Otherwise, in warm weather, the structure would buckle. Next then, we're given here a picture of a bimetallic strip, okay, and you're asked, suggest a reason why it curves one way when heated and the other way when cooled. So if we look normally, the brass and the steel, they're going to end up with the same, making a straight line. However, when I heat it, what happens is that it curves downwards, and on top I have my brass. So what happens is that the brass here is going to expand more. Okay, so if you look at this, there's more of the brass expanding than there is of the steel if you were actually to measure it. So the brass here expands more than the steel when heated. And then you're asked when cooled. So if I look here, when it's cooled, my steel actually contracts more. So because it contracts more, it causes the bimetallic strip to go upwards. And a practical use for this is that it's used on a thermostat, the switch on a thermostat on radiators. So for example, when a radiator gets to a certain temperature, okay, it's going to stop, okay. It's going to stop heating that radiator because it's already heated to its max, as indicated by the thermostat.